Good morning everyone. Welcome to another electrifying class of SISYA class. And very good morning to all our 10th boarders. Okay, so as all of you know me, I am Akash sir, your chemistry master teacher from SISYA class. And here, as you can see already, I have brought up a new session for your 10th board exams, okay, of metals and non-metals. And as you all know that this is a very important chapter and a very scoring chapter as per your board exams, because you have been learning about metals and non-metals since last 2 to 3 years. Okay, so you might be knowing about the basics of this chapter. Still we'll start from the scratch, we'll start from zero, basics se start karenge, then we'll move on further. Okay, and as you all know, in the end we'll be solving the MCQs and the most probable questions that could come in your upcoming board exams. Okay, so this session is very important for all the 10 boarders. And as I have already been saying in my last videos also, that even if you don't know anything about this chapter, then also you can watch this video very carefully. I'll be starting from zero, and if you watch this video very sincerely, then you'll be able to solve all the questions related to metals and non-metals. Okay, so not making much delay, I'll start the chapter. This is a long chapter, so be patient, be calm, and be connected with me. Okay, let's start. So before starting, let us discuss about the periodic table classification. Okay, now you all must have seen this periodic table. Okay, now this chapter has been omitted from your 10th board exams, but this periodic table is very important for each one of the chapters of chemistry, especially in your class 10th. Okay, now why I have shown you this periodic table? Just to give you the basics about what metals are what metals and non-metals are and where are they placed in the periodic table. So now, as you can see this in the periodic table, these are your groups. These are your groups, that is 1 to 18, and these are your periods, that is 1 to 7. These all of you might be knowing. Now, this from group 1 up to group 12, these are basically metals. These are all metals. Okay, now mostly from group 13 to 18 are mostly non-metals. Now there are again bifurcations, like your group 1 is alkali metals, because they basically dissolve in water to form alkalis. Okay, that we'll be seeing in the coming chapter. Now group 2 is your alkaline earth metals. Okay, so these are found in the form of minerals and ores inside the earth's crust. That's why they are called alkaline earth metals. From group 3 to group 12, these are transition metals, because they have variable oxidation states, so they are used for various purposes. Okay, now from this group 17, this is known as halogens. These are most electronegative metals, non-metals, most electronegative non-metals. Okay, and your group 18 is your inert gases or noble gases. So these are some important groups. So I've just tried to mention it so that you must be remembering while going through this chapter. This will be helping you in solving questions from this chapter. Okay, now let's move on. So let's start from the basic. Okay, then we'll move on to the chapter very quickly. Okay, so elements. Now elements, what are these all? So these all which you can see in the periodic table, these are all elements. Okay, elements are those substances which are comprised of same type of particles, and they are called atoms. Now you can classify these elements according to the periodic table on the basis of metals, non-metals, metalloids and noble gases. I have already told you about metals, non-metals and your noble gases. And talking about metalloids, then you can see this zigzag line. You can see this zigzag line. So this zigzag line is your metalloids. So basically, which elements come under the category of metalloids? So just silicon, germanium, arsenic, tin, tellurium, all these are your metalloids. What are metalloids? Metalloids, as you can see, these are sandwiched between metals and non-metals. So they possess both the properties of metals and non-metals, some of the properties of metals and some of the properties of non-metals. So these are basically used in our semiconductors, okay, for making semiconductor chips, okay, in communication sector, basically these metalloids are used, and there is so much more use of these metalloids as we will be seeing. Okay, these are also used in making alloys also. Okay, so we'll be seeing it further in the chapter. Now, yes, now let's move on. Let's start from metals. Okay, so what are metals basically? So metals are basically cations. Why they are called cations? Because when you see the valency of these metals, now you already have learned about valency in your grade 9. Okay, so I have just given you an example of this also. So if you don't know about the valency, then you will be understanding it. So as you know here, sodium atom, now sodium has the valence, sodium has the atomic number of 11, and writing the electronic configuration, it's 2, 8, 1. As you can see here, it possesses 1 electron in its outermost shell. So now it's easy to lose 1 electron beta rather than gaining 7 electrons. Okay, so it will lose that 1 electron as I have written here, and it will form a sodium ion, and that is nothing but a cation. And since it is losing 1 ion, therefore the charge comes positive. So it is Na plus. So it becomes Na plus by losing that 1 electron. Okay, now some metals have 2 electrons in their valence shell, some have 3. Okay, mostly they have 1, 2 or 3 valence electrons in their outermost shell. So they lose those electrons and they form cations. Okay, now this will be helping us in the formation of ionic compounds. That is very important part of this chapter. Okay, that's why this is very important. Now talking about non-metals, it is just the reverse of metals. Okay, so when you will see its configuration, like let us take the example of chlorine. So chlorine atomic number is 17. So the configuration will be 2, 8, 7. How do we write this configuration? There is a rule, okay, according to which in the first shell maximum electrons that can be accommodated is 2. In the upcoming shells, that is second, third, fourth and so on, there will be maximum 8 electrons in their shell. Okay, so likewise we fill the electrons as per the atomic number, and from there we get the valence electrons. So as you can see here, it is 7 valence electrons. Now to complete its octet, all of these elements follow the octet rule. Okay, they want to have 8 electrons in their outermost shell so as to become stable, like noble gases. So it is easy to gain 1 electron rather than losing 7 electrons. So it gains that 1 electron, as you can see here, it gains that 1 electron and it forms chlorine negative anion. Since 1 electron is gained, therefore 1 negative charge. If 2 electrons will be gained, there will be 2 negative. If 3, there will be 3 negative. Okay, now, so this was about metals and non-metals, that how they lose or gain electrons to form ions. Why it is important? Because these ions will be combining to form ionic compounds, which we'll be seeing in the chapter later. Now let's talk something about metalloids and noble gases. I already have introduced you the metalloids. Still you can see here boron, silicon, germanium, arsenic, antimony, tellurium. These are mostly your metalloids. And the most commonly used metalloids are your silicon and germanium. And as I have told you, they are mostly used for making semiconductor chips for in LEDs. Okay. Now, noble gases, these are, though why they are called noble gases? Because they are chemically inert in nature. Inert matlab they do not react with other elements. Why they do not react? Because they have complete octet. If you see the electronic configuration, they have either 2 electrons or 8 electrons in their outermost shell. So they don't have to react and form cation or anion. Okay, like neon, it will be 2, 8. Helium, it's 2. Argon, it will be 2, 8, 8. So as you can see here, it has complete octet or duplet. That's why they do not react. Now, let's start with the chapter. So we'll be starting with the physical properties. Okay, so before talking about physical properties, let's discuss what is the basic difference between metals and non-metals that you have learned till now. So now this is the basic difference between metals and non-metals that you have learned till now. So as you can see here, let's talk it one by one. So physical state, now you all know that mostly metals are solids except mercury. Now these exceptions remember, because we'll be solving MCQs and one of the questions can be coming in your final exams in MCQs regarding your physical properties. Okay, so talking about physical state, all metals are solids, okay, except mercury. Now I have put exceptions otherwise also. So we'll be discussing exceptions after this difference also. So mercury is an exception of metal which is liquid. Talking about melting and boiling points, most of the metals will have high melting and boiling points because they are very reactive. Okay, so they will not get melt easily or boil easily. Okay, now there are some exceptions also we'll discuss. Luster, now metals show bright metallic luster, okay, like silver and gold. That's why they are used in making jewelries. Now malleability, what is malleable? To be beaten into thin sheets. So you can form thin sheets with the help of these metals or foils, like aluminium foils, which you use for packaging food materials. Talking about ductility, now what is ductility? Ductility means to draw something into wire form. Okay, so these can be rolled into wires also, like copper wires, that is used in electrical conductivity process. Now conductivity, they are very good conductors of heat and electricity. They pass on heat and electricity very easily. Now talking about non-metals, non-metals exist in all three states, some in solid, some in liquid, some in gases, like hydrogen, oxygen, nitrogen, these are gases. Bromine is an exception because very few non-metals are there which are present in liquid. So one of them is your bromine. So bromine is the only non-metal that is present in liquid form. Now few are solids also, like carbon, sulfur and phosphorus. So there are mixed combinations in case of non-metals. Good morning, Divyansh. Good morning. Now the melting and boiling point of non-metals are comparatively low, okay, as compared to your solids. Now these are generally dull non-metals except iodine. So remember these exceptions. So iodine has shiny bright luster in spite of being a non-metal. Now non-malleable and non-ductile. These are non-malleable and non-ductile as most of them are gases. Now these are bad conductors of heat and electricity except the allotropes of carbon, that is graphite. Graphite is that allotrope of carbon. Now allotropes are something which appears different but they have same chemical properties because they possess same chemical composition. Okay, so one of them is graphite. So this is a good conductor of electricity. Okay, now some questions related to your physical properties and the basic difference which I have just told you. So now which of the following is a physical property? Yes, which of the following is a physical property? Yes, beta, graphite, diamond and Buckminster fullerenes. These are allotropes of carbon. Now which of them is a physical property? So density is your physical property because corrosion is basically rust due to the presence of moisture and oxygen. Reactivity itself says it is a reaction, and flammability is reaction in the presence of oxygen. So all these are reactions except density. So your answer will be density. What is the ability? No, it is not D beta. It will be C. Which is the ability of a substance to be hammered into thin sheets. Now I have just told you that if we hammer something into thin sheets, it is your malleability. So these properties you must remember. Now talking about the boiling point of water. Now boiling point of water, I have already told you about melting point and boiling point. So this is a physical property, as you can observe it physically, whether a substance is getting melted or converted into steam. So it's a physical property. So your answer is B option. Yes. Now which of the following properties can be observed without changing the composition of a substance? Okay, now if I am not changing the composition, now we already have learned about physical and chemical properties. So if we are not changing the composition, that is your physical property. Always remember, in physical property only the state change, size, shape, color or state changes, no chemical combination changes observed. Okay, so that's your physical property. What is the ability of a material to be drawn into wires? We have just discussed about it. So that is your ductility. Yes. Which of the following is not a physical property? So now not a physical property, then I have just told you that any reaction that is occurring in an element, that is your chemical property. So if it reacts with acid, so this reactivity with acid will be your chemical property and it's not a physical property, whereas color, hardness and melting point, all these are physically observed. So these are physical properties. Yes, it's C. Now the property due to which metals produce sound. Sound. What is that called? So that is your sonorousness. So metals are sonorous because they produce sound. Like iron, okay, you can produce sound with iron. Okay, so that is an example of property of metals which produce sound. So that is sonorousness. Next, which property helps to identify a pure substance? Now, if you have to identify whether a substance is pure or not, whether it's an element or not, or whether it's a compound or a mixture, then what is the property that helps us you to identify that whether it's a pure substance or not? So now this is an important one and a tricky one. So that's your fixed melting and boiling point. Yes. So any pure substance which consists of same composition will always have a fixed melting and boiling point. Remember these students. Okay. Yes, it's B. Okay. So now this was about the difference between metals and non-metals. Now I have already told you about some exceptions. Now we'll discuss these exceptions in detail. Then we'll move on to the chemical properties. So now talking about exceptions, now just remember these exceptions. You can also note it down. So in hardness, you know metals are hard, non-metals are not so hard. But there is an exception in non-metal, and that is again the allotrope of carbon, and that is diamond. So diamond is a non-metal that is your hardest non-metal. Okay. In metals also there are some exceptions, that some very reactive metals like sodium, potassium and lithium, they are so soft that you can cut it with the knife. Okay, so these are soft metals. Now we will be having questions related to this. Questions have been asked related to these exceptions in the last few years. So this is important. Now talking about ductility, metals are ductile. Now best ductile metals are your gold and silver. That's why they are used in making jewelries and they are so expensive. Now non-metals are brittle, they break easily. Okay, so now these are some non-metals which are the exceptions. Okay, like zinc, tin, lead, arsenic, like your mercury, gallium. These are some non-metals that are non-ductile. Okay, that means they can be drawn into wires. Okay, but they are not that ductile. That's why they are not used that efficiently. Now, talking about malleability. So now malleability, now mostly metals are malleable, as I have already told you. Now again the best ones are silver and gold. Now non-metals are non-malleable, but again these are some non-metals like zinc, arsenic, tin, mercury, gallium, which are malleable. So these are some non-metals which are ductile and malleable. Now talking about electrical conductivity, now metals are good conductors of electricity because they have valence electrons in them. Okay, and because of that valence electron, best one is your silver. So now you know about copper, you know about aluminium. Okay, so these are some good conductors. Now non-metals are poor conductors because they do not have any free mobile electrons in it. Okay, now some exceptions: poor conductors of electricity, bismuth and tungsten. These are some metals which are poor conductors of electricity, and good conductors of electricity in non-metal, it is graphite again. Yeah, no free electrons, that's why in absence of free electrons, they cannot conduct electricity. Some more properties and some more exceptions. Now, conductors of heat. So best one is your copper. Okay, now non-metals are poor conductors. Okay, now there is one metal, that is your lead, which is poor conductor of heat. Okay, similarly there is one non-metal which is good conductor of heat, and that is a graphite, allotrope of carbon. Now melting and boiling points, normally metals have high melting and boiling points. Now non-metals have low, but there are some exceptions. Metals with low, that metal which has lowest melting and boiling point, that is your cesium. And non-metal with high melting and boiling point, again graphite. So as you can see this, in non-metal, these allotropes of carbons are mostly exceptions. Now talking about sonority in the last, now it is about sound when it strikes, and non-metals do not produce sound when hit, but mercury and gallium, these are some non-sonorous metals. Okay, mercury and gallium. Now mercury is only the liquid metal that is present in liquid state, that's why also it is non-sonorous. and the last one is luster. So mostly metals are lustrous like gold and silver. Now non-metals are non-lustrous, but there is one exception, and that is your graphite and iodine. Diamond graphite, that is allotropes of carbon, and iodine. Iodine is very important. This has been asked in some previous exam question papers, that iodine is the non-metal that is lustrous. Next, some questions related to exceptions, then we'll move on. Which of the following liquids, metals is liquid at room temperature? So I'm talking about metal and I am talking about liquid. Now I have already told you that solving MCQs faster, you have to just search for keywords. Those keywords you don't have to read the whole question again and again. Reading once, just search the keywords and linking those keywords, you will get the answer. Okay, so metal and liquid, it is mercury. Non-metal and shiny lustrous, we have just discussed, it's iodine. Metal and soft, cut with a knife, now sodium, potassium and lithium. So here the option comes sodium. Non-metal and conducts electricity. Now I have told you that most common non-metal exceptions are your allotropes of carbon, that is graphite and diamond. So which non-metal conducts electricity? Graphite. But what about tricky questions in which they may ask for which is incorrect and more? But there is one more trick that you can apply in solving MCQs, that if you don't know the answer, or if you are getting confused, just try the elimination method. Okay, just try to negate those options which you are sure that they can't be the answer. And in those 4 options, at least 2 options must be there, which on reading the question twice, you will be observing that those 2 options can't be the answer. Then you are left with just 2 answers, 2 options. So even if you have to guess, then there is a 50-50 probability that you might be correct. Okay, so in those questions in which they'll ask about incorrect also, then there are some options, at least 1 to 2, that will be correct. And that on reading twice, you'll be observing that that is correct. So you can negate those options. That will increase your confidence also, that now these 2 options are left. So there is more chance that if I'll guess also, knowing the basics, then I'll be correct most of the times. Yes. Next, which metal is non-sonorous? That doesn't produce sound. Now I have just told you that lead is that metal which is non-sonorous. Next, which non-metal exists in liquid form? That also I have discussed. Bromine is the non-metal that exists in liquid form. It is the only non-metal. Yes, the next session will be carbon and its compounds, maybe day after tomorrow, within 1 to 2 days. But this week only we'll be completing that chapter also, and maybe on Saturday most possibly we'll see, I'll be having a complete class for all the 4 chapters, the complete class for chemistry. Okay, the last few tips and tricks that I'll want to discuss with you all regarding solving these 4 chapters, how I'll be solving chemistry with utmost efficiency, so you can do better. And you can just reduce the mistakes that mostly students makes in the board exams. Okay, because solving chemistry part is quite tricky. You will not be finding very big questions, long answer questions. Even in long answers also, you will be finding its subparts. So in chemistry, you have to write less, you have to think more. Okay, so you have to think smart also in order to gain more marks in chemistry. Okay. So we'll be having one or two sessions in this week of chemistry. So do get connected in order to score good. Next question. Which of the following metals has low melting point compared to others? Now I am talking about melting point, low melting point. Now which we can cut easily will always be having low melting point, and that is nothing but your sodium. Next. Yes, beta. I will be solving competency based questions also. I am having some competency based questions in the PYQs also in today's class. In the upcoming classes, I will be coming with more competency based questions. Okay. Now, which non-metal has very high melting point and forms a hard crystal structure? Now here, what is the keyword that I was asking for? It is that hard crystal structure and non-metal. Then your mind should strike directly to the diamond part. Okay. Next, which metal is poor conductor of heat compared to other metals. Now I am talking about poor conductor of heat. Okay. Now there is lead, copper, iron and silver. Now you already know that iron and copper are good conductors of heat and electricity. I am talking about poor conductor of heat. Okay. So if we can go back to that slide which I have already told you. Now here I already told you that these are good conductors of heat. Okay. Now what I have told you in the exceptions, that poor conductor of heat is lead. Okay. So now as you can see, these are all exam based questions. So if you know these exceptions, then you can solve these questions very quickly. Okay, so your answer is lead, PB. Yes. Which of the following metals is non-ductile? Now I am talking about metals and I am talking about non-ductile. Okay, then you can again go to those questions. Now just answer me, which of the following metals is non-ductile? Yes, so now this is somewhat easy because you already have been learning about metals and non-metals in the last few classes. Okay, so now I am asking about which of these metals is non-ductile. Yes, it's your zinc. Next, so now moving on to chemical properties. Okay, so this was all about physical properties which you already have learned in your lower grades. Still that is important, especially related to your case based questions or your MCQs. Okay, some questions can be asked in that. Now, chemical properties of metals and non-metals. Now, this is important. Okay, now some of you must be knowing about this chemical properties, but if you're not knowing about this anything, then also you can just watch this class. I will just start from the basic itself. Okay, so as you can see here, that now reactivity series is very important if you want to solve questions related to this chemical properties. Okay, now we have already discussed about this reactivity series in all the previous chapters also. Okay, so potassium, sodium, lithium, calcium, magnesium, aluminium. Okay, so all these this series is very important. Okay, now as you can see this with the help of diagram, potassium is the most reactive metal, then comes sodium, then lithium, calcium, then as you go on, okay, as you can see the flames also, it is going on reducing. That means it goes on decreasing the reactivity with oxygen. So now this is very common experiment that you have seen in your first chapter, that magnesium ribbon experiment. Okay, now this magnesium ribbon experiment, now again I'll recall you, if you just burn this magnesium ribbon, okay, in air, then what it will form? It will form magnesium oxide. Now just balance it. So this is your reaction of this magnesium ribbon experiment, and what you will be getting? You will be getting magnesium oxide with white dazzling flame. So what does this concludes us? This concludes us that mostly metals in reacting with oxygen forms metal oxides. So what do they form? Metal oxides. Why do all these elements have their own colored flames? But all these elements have their own colored flames because in class 8 you have already studied about combustion and flame. In that you have studied about in combustion or in flames there are different colors that is related to the amount of combustion that is happening. If there is a complete combustion, then it will show a flame of different color. If it is incomplete, so in different layers it shows different colors depending upon the amount of combustion that is happening. Okay, so those flame colors depends upon the amount of combustion or how vigorously or how slowly that particular metal is reacting with oxygen. Okay, yes. Now this was about metals with oxygen. So now talking about metal oxides. So these metal oxides that you are getting, what is its nature? Now this nature of metal and non-metal oxides are also very important. Okay, so remember that I'll be asking questions. So metal oxides are basically basic in nature. Okay, as metals have the tendency to lose electrons, so they readily react with oxygen and water. That's why they form basic oxides. Okay, they dissolve in water. Okay, and dissolving in water, what do they form? They form alkali. Now alkali are those metals which readily dissolve in water, so they form a solution called alkali, and some of them forms non-alkali solutions also, like copper, less reactive metals will form non-alkali compounds. Now more reactive metals like sodium and potassium will form sodium hydroxide and potassium hydroxide in water, that is your alkali compounds. Now some metal oxides are amphoteric also. Now this is very important word. This amphoteric oxide will be discussing and solving many questions related to this in today's class only. I'll just be giving you two examples right now. One is aluminium, another one is zinc. These are those two metals that are amphoteric oxides. That means their oxides react with acid as well as base. They react with both, and in both the cases they form salt plus water. Okay, so that's why they are called amphoteric oxides. Those oxides which react with acid as well as base. So they form acidic and basic salts both. Okay. Okay. Happy birthday, Sai Ritvik. Okay. Now let's move on. I hope it is clear till now. Next. So now these are some examples. So as I have already shown you that metals react with oxygen to form metal oxides. Okay. Now these are some examples. Copper reacts with oxygen to form copper oxide, that is black in color. Now aluminium reacts with oxygen to form aluminium oxide. So these are some common reactions. Okay, and as you go down the reactivity series, the reaction with oxygen also goes slow down. Okay, and the least reactive metals like silver, gold, platinum, they do not react with oxygen. Now some variations. Now I have put some points related to variations. Now why I have put these points? I have put these points because some questions have been asked related to this in our exams. Okay, now as you can see here, potassium and sodium, these reactivity variations are very important. You can also note it down. Potassium and sodium, they are most reactive metals, so they will react instantly with oxygen. At normal temperature, at normal room temperature, they will instantly react with oxygen. That's why they are not kept in open air. They are kept in kerosene oil. Why they are kept in kerosene oil? Because kerosene oil prevents the oxidation of these metals. Okay, now coming to moderate reactive metals like magnesium, zinc, now they require heating. Without heating, they will not react with oxygen. So you have to provide temperature, and on reacting they will also release light. Okay, so they will form a bright white light. Yeah. Now low reactive metals like copper, they react very slowly in air and they form oxides. Now noble metals, they do not react with oxygen even when you give them temperature. So these are some reactivity variations. Okay, I'll also discuss about non-metals reactivity variations. Questions comes from these reactivity variations. Some give reason type questions. Okay, so it is very important. Next. Now coming to non-metals, reactions of non-metals with oxygen. Now if I'll talk about non-metals with oxygen, then I have put some examples. Okay, like nitrogen, mostly these are gases, nitrogen, nitric oxide. So on reacting with oxygen, they mostly form gases only. As you can see here, nitric oxide and nitrogen dioxide. So mostly they form gases only that are present in atmosphere. Okay, next. Now I have combined this metal oxides and non-metal oxides in one slide, okay, to make it clear and easy for all of you. Okay, now after the class, if you find some slides very important as they are, you can note it down and make your notes also, okay, for last time revisions. So now as you can see here, I have given the examples of some oxides which are the combination of metals and non-metals. Now if I'll talk about metal oxides, okay, now they in water mostly form hydroxides. So when oxides, metal oxides react with water, they form hydroxides and mostly they are basic. That's why I have mentioned the pH will always be greater than 7. But if I'll talk about non-metal oxides, mostly they are gases that are present in the atmosphere. Now in reaction with water, they will form acids like this: carbonic acid, sulfurous acid, nitric acid. Okay, so they will form acidic oxides. Okay, and they will be, their pH will be less than 7. Okay, so now this is very important. Next. Now something about your acidic nature or something about non-metals reactivity variations. Now they show acidic nature in water, these non-metals oxides. Now, why they show acidic nature? Because they increase the concentration of hydrogen ions in water. Whenever you react these gases, these oxides, non-metal oxides in water, the hydrogen concentration is increased. That's why they show acidic nature. Okay, like carbon dioxide, sulfur dioxide, and nitrogen dioxide, common non-metal oxides, we already have seen it. Okay, they'll forming the respective acids. Now, talking about their physical state, they are usually gases at room temperature. Okay, now mostly non-metal oxides are acidic. Some of them are neutral also. So this is an exception for non-metal oxides. Metal oxides are mostly basic, but non-metal oxides can also be neutral. Now, which are those non-metal oxides? Like carbon monoxide, a very poisonous gas, nitrous oxide, and nitric oxide. Now, mostly these gases are produced in factories. Okay, these are the byproducts of the reactions that takes out in industries. Okay. Okay, so now let's move on. This was about metals and non-metals react with oxygen or air. Now some questions, then we'll be seeing the reactions with water and acids. So now when aluminium reacts with oxygen, it forms aluminium oxide, and this layer protects the metal from further corrosion. So this aluminium oxide layer, that is your Al2O3, this will protect the metal from further corrosion. Okay, so now what is property that it is showing? It is showing protective oxide layer formation. As I have already mentioned here, protects the metal. So this was your keyword here. Okay, now some of you might be thinking that amphoteric nature, because whenever aluminium comes to our mind, aluminium oxide, the first thing that comes is amphoteric nature. So that's why, to confuse you, these option has also been given in your question. Okay, but you have to search for that keyword before solving it. Next, magnesium reacts with oxygen to form magnesium oxide. So it is MgO. We already have seen the magnesium ribbon experiment. Now this is basic, as metal oxides are basic in nature. Now which oxide will show the acidic behavior? For acidic behavior, so this is the keyword, this acidic behavior. Now for acidic behavior, you have to search for non-metal oxide. Now only one of them is non-metal, that is your phosphorus. Then you don't have to search for more. Your answer is phosphorus pentoxide. Next, now a student heated sulfur in the presence of oxygen. So what will be formed? Sulfur oxide, sulfur dioxide, SO2, and he dissolved it in water. So now this is a non-metal oxide, and if you dissolve non-metal oxide in water, now you will get acid, as we have already seen. Now this is turning blue litmus red, so it is acid. That is clear. So one of the thing that is clear is your sulfur dioxide is acidic, and it forms either sulfurous acid or sulfuric acid. That makes the rain acidic. We have discussed it in the last chapter also. Next, now what happens when iron reacts with oxygen and moisture? It gets rusted. Okay, you all know hydrated iron oxide, Fe2O3.XH2. We already have learned that in the first chapter. So now when iron reacts with oxygen and moisture, it gets rusted. Now when the same reaction is prevented by painting, now if you paint that, rusting will stop. Now what does this indicate about the role of oxygen? Now the role of oxygen is required for rust formation. So two things that is necessary for rust formation is oxygen and moisture. Okay, so these two things are necessary for rust formation. Okay, now, yes. Now, next question. Non-metals like carbon forms both acidic and neutral oxides. We have seen carbon dioxide is your acidic in complete combustion. Carbon monoxide is your neutral in complete combustion. Okay, so carbon forms both oxides. Okay, now what does this show about carbon's behavior? That carbon shows multiple oxidation state. Now what is oxidation state? Now listen carefully. Now here you already know that the valency of oxygen is -2. So if there are two oxygens, it will multiply it by 2. So here the oxidation state is -4. To balance it, the oxidation state of carbon will be +4. So in CO2, the oxidation state of carbon is +4. But if we see it in CO, now here the oxygen is again -2. So to balance it, the carbon will be +2. So as you can see here, same element but showing variable oxidation states. Okay, so remember this. Most of the elements that are forming both neutral and acidic oxides show multiple oxidation states. Yes, beta, I also take grade 9 classes. Okay, right now we are concentrating on boards. So this is the revision course for boards. I'll also be coming in the upcoming days with your 9 class chapters. Okay. Now you can also ask some doubts, okay, in the coming classes if you have for 9th. I'll be having a separate class for 9th grade also. Now next question. So now which of the following metals react slowly with oxygen? Now read the question carefully. Okay, now concentrate here. So now metal reacts slowly with oxygen to form a black oxide coating. So what is the keyword here? It is black oxide coating. Now whenever black oxide coating comes into your mind in chemistry, it is nothing but your copper oxide. So these few important keywords you must remember, that whenever black color coating comes, it is copper oxide. Whenever blue color solution comes, it's copper sulfate. Pale green color, it's iron sulfate. So these few things you must remember. Okay, it will help you a lot. So the option is copper. Yeah. Next. Non-metals generally form which kind of oxides when they react with oxygen? So mostly they form acidic. Now to confuse you, neutral has also been given in the option, but you don't have to be confused. Mostly the non-metals form acidic oxides. Some also form neutral oxides, mostly in the presence of incomplete combustion. Okay. Yes. Next. So now this was all about reaction of metals and non-metals with air. Now we'll move on to water and acids. Okay. So now as you can see here, I have put various metals here in different glass beakers and I've tried to dissolve them in water. Now as we have already discussed earlier also, that metals, normally very high reactive metals, those are placed high in the reactivity series like potassium, sodium, they directly react with water to form hydroxide. But some metals that are not that reactive, now they do not react directly to form hydroxides. They first form oxides, then again on reacting oxides with water they will form hydroxides. So it's a two-step reaction for medium reactive metals. Okay, and this is very important as we'll see. Okay, now let's just concentrate. So now this is the reactivity series. Now just learn this reactivity series by heart. Okay, because most of the questions from different chapters will be asked somehow related to this reactivity series. Okay, so now potassium, sodium, lithium, most reactive metals. Then calcium, magnesium, aluminium, medium reactive. You can also put zinc and iron in this. Then this lead, copper, silver and gold are your least reactive metals. Now copper, now this silver, gold and platinum almost do not react at all. Okay. So now I have tried to put this whole water concept in a table form. So now try to make these tables and learn these reactions in the form of tables. It will help you very frequently in scoring good marks. Okay, for that you just need to know about balancing the reactions. Okay, you must know how to balance the reactions, how to form the reactions. So now as you can see here, potassium, sodium, lithium, these are so reactive that they react violently even with cold water. Even with cold water they will react very violently and they will form their hydroxide. So this reaction will be violent and they will form hydroxide directly. Now if I'll talk about calcium, it is a fast reaction. Okay, so it reacts rapidly but not that violent. If I talk about magnesium, it is very slow. Okay, now these are medium reactive elements. Okay, now if I'll talk about zinc, usually no reaction. Cold water, I am talking about cold water, then we'll see hot water and steam also. So for medium reactive metals, either you have to use hot water or you have to use steam. Now iron only forms rust, they do not easily react. Copper and gold shows no reaction with cold water. So what is the conclusion? That only most reactive metals react with cold water. Now let's see an example of calcium. So now calcium reacts with cold water to form calcium hydroxide. Okay, that is your slaked lime, okay, and lime water, and your hydrogen gas is evolved. How can you observe this hydrogen gas? By taking a matchstick, it will produce popping sound and it will show bubbles. Now that denotes your hydrogen gas. Now this one important information about non-metals with water. There is one important information regarding non-metals. What is that? That non-metals, when react with water, they form covalent bonds. Okay, so non-metals mostly form covalent bonds. Now, why do they form covalent bonds? Because non-metals mostly form anions. I have already told you. Now, anions have the tendency to gain electrons. Okay, now if non-metals will react with water, now they will not be able to break the ions of water. Okay, that's why they will be sharing electrons, because as you can see here, if there is one non-metal and there is another non-metal or metalloid, now both wants to gain electron. Okay, so now nobody is eager to lose an electron. So what will they do? They will just share these electrons. Okay, that's why they form covalent molecules. Okay, but that's very important for the exams. Okay, so at least for the next few days you have to learn this chapter. Okay, so now this I have kept it in one slide. You can just learn it, that in cold water, hot water, steam, and which of the metals that do not react. So now as you can see here, in cold water they will produce metal hydroxide and hydrogen gas is released. Now which of these metals react in cold water? Very reactive metals like sodium, potassium, calcium. Calcium reacts less violently. This is a rapid reaction but not that violent. Okay, now hot water, it also produces metal hydroxides and hydrogen gas is released. So this is common in all of them. The example is calcium. Okay, so for if you have to do the reaction fast, so you have to use hot water for calcium. Now if I'll talk about steam, the example is your aluminium and iron. Okay, so aluminium and iron forms hydroxide, that is ferric hydroxide, or your aluminium hydroxide using steam. And lead, copper, silver and gold do not react at all. Okay, not even with steam. Okay, now what is the reason? Now this is an important question. Give reason question for your upcoming board exams. That why do non-metals do not react that readily with water? Because they form covalent bonds. Why do they form covalent bonds? Because non-metals have high electronegativity beta. It has a tendency to gain electrons. So they are highly electronegative. Now, because of that, they'll share these valence electrons to be stable or to have their octet complete rather than transferring them. Because both the atoms, both the non-metals or metalloids, they have the tendency to attract electrons. So sharing is more favorable than losing or gaining here. Okay, so that is the reason, because non-metals form covalent bonds. Yeah. Now some questions related to water. So when sodium reacts with water, what is formed? Sodium hydroxide plus hydrogen gas. So if you know the reactivity series very well, that which of the elements or which of the metals are very reactive, then you don't have to write the reaction also. Without writing the reaction also, you can solve this question. Now which metal reacts vigorously with cold water? Again reactivity series. So which of them is most reactive? Sodium. Now which metal reacts slowly with steam to form metal oxide and hydrogen gas? Now we have just seen two metals, aluminium and zinc. So one of them is there, aluminium. So now knowing these exceptions and these reactivity series and knowing that table which I have formed for you, okay, you can easily solve this MCQs or case-based questions. Which metal do not react with water under any condition? So I have just told you that iron, copper, gold and silver do not react with water under any. So iron is also there, gold is also there. Now out of them, iron and gold, if you have to select one option, then which will you select? Now the least reactive of both of these is your gold. So your correct answer is gold. So sometimes they'll give you two options, both of them can be slightly correct, then you have to opt those options which is more correct. Okay. Now magnesium reacts with hot water. It doesn't react with cold water because it is medium reactive, and what it will form? So any metal that reacts with water, it always forms hydroxide and hydrogen gas is released. So your answer is option A. Next, which of the following gases is released when a metal reacts with water? So when a metal reacts with water, which gas is released? Hydrogen. Next, which metal does not react with cold water but reacts with steam to form oxide and hydrogen gas? Okay, now we have seen that some metals do not react with cold water but they react with hot water or steam. So for now we have to see which is less reactive out of these four. Now these three are more reactive. Okay, so your answer will be zinc. Which of the following does not react, which of the following metals reacts slowly with cold water and forms bubble of hydrogen gas? Now slowly with cold water there is only one metal, that is your calcium. Non-metals generally react with water to form. So non-metals generally react water to form. There is no reaction. Now we have seen that reason that why non-metals do not react with water, because they form covalent bonds. They are highly electronegativity. Okay, they are highly electronegative and they have high electron affinity. So they want to gain electron. So they probably share electrons instead of transferring them. That's when no reaction is possible. Okay, so this was all about reaction of metals and non-metals with water. Now let's move on to the acids, the last part. Okay, now this is a very common diagram that you have been seeing in chapter 1, chapter 2, and you will be seeing it till your last chapter. So now this is a very common experiment that you have seen in your 10th grade, that we are putting some zinc granules in dilute sulfuric acid. And what are we getting? We are getting hydrogen bubbles. Okay, now we can see the reaction first. So if you'll put zinc granules in sulfuric acid solution, then again the reactivity series comes. So now zinc is more reactive than hydrogen. So the displacement reaction will occur. If any more reactive element is dipped in a solution of less reactive element, it will displace the more reactive element and forms a salt solution. So what it will form? It will form zinc sulfate and hydrogen gas is liberated, which you can see here in the form of bubbles, and also you can experiment it with a popping sound using a burning candle. Okay, so now this is the reaction of metals with dilute acid. So only if you remember this one reaction, now the whole concept of reaction of metals with acids is clear. So what does it form? It is a displacement reaction, and if a more reactive element is dipped in a less reactive solution, then it will form a displacement reaction and a salt solution will be formed along with the release of hydrogen gas. Okay, so now this was about reaction of metals with acids. Now if I'll talk about non-metals with acids, now the same concept goes here also. Non-metals do not react with water also. Now non-metals will not react with acids also. Why? Same reason, because they form covalent bonds. They are already acidic in nature. We have seen its properties. They are already acidic in nature. Some are neutral. So now they are not so favorably eager to react with dilute acids because they want to form covalent bonds. So they do not react with acids because they are electron acceptors. Okay, they are electron acceptors. Now acids are also electron acceptors. So now acids need electron. So acids need an electron donor so that it can release hydrogen gas. Now when hydrogen gas is released, when it will get an electron donor. But non-metals are not electron donors. They are also electron acceptors. That's why they cannot donate electrons. That's why mostly this reaction is not possible. Still, sometimes or some non-metals like sulfur, okay, they can react with highly concentrated acids. They will not react with dilute acid, but if highly pure concentrated acid like nitric acid is there, then they react with them under special conditions. So no normal reaction is observed in that condition also, and in that condition also they will be forming oxides, okay, and other products, and they will not be releasing hydrogen gas. So no hydrogen gas is released when non-metals reacts, even if it reacts with acids. So this reason is very important. One question can be asked from this non-metal section, that why do they not react with water or acids. Okay, now the last part of this chemical properties is reaction with salt solutions. So now, if metals will react with other metal salt solution, then what it will form? We have just seen the reaction. Okay, they will form displacement reaction, and if there is a more reactive metal, then it will replace a less reactive metal. Okay, now it all depends upon the reactivity series, whether this metal will react in metal salt solution or not. Like we have seen the example of zinc and sulfuric acid. Okay, or zinc or copper sulfate also. Okay, if it is a less reactive element, then no reaction is possible. If it is a more reactive element, it will displace the less reactive element from its salt solution. Okay, so now this is one summary of all the chemical properties. So after class, you can note down this summary. So even through this table, you can get the complete knowledge about how metals react with air, water, acids and salt solution. So metal react with oxygen to form metal oxides. Now it reacts with water to form metal hydroxides. And hydrogen gas is evolved. So this is important. And now it reacts with dilute acids, displacement reaction. Here also we get salt along with hydrogen gas and we get salt, metal salt. Now metal salt solution, if it is more reactive metal, then it will displace less reactive metal and displacement reaction occurs. Okay. Now metal oxides are basic in nature. Okay, some are amphoteric also, like zinc and aluminium. Now metals reacts with cold water, sodium and potassium, highly reactive. Hot water, magnesium, calcium, medium reactive. Steam, aluminium, iron, zinc, again medium reactive. Do not react, copper, silver, gold, platinum. For these reaction to occur, metals in element form should be more reactive. So for acidic reaction, metal should be more reactive, then only displacement reaction occurs, and same goes with metal salt solutions also. Okay, so this was all about metals, because non-metals generally do not react. Okay, that's why mostly questions comes from chemical properties of metals. From non-metals, only that exception can come, that why they do not react with dilute acids or water. I have explained you the reason very prominently. Now you can note it down also. Okay, and you can ask me also again if you are having any doubt. Okay, now some questions related to acids. Now when zinc react with H2SO4, so now here just you have to remember the chemical reactivity series. So now if zinc is more reactive, then it will form zinc chloride and hydrogen gas is released. So this is the reaction. It will form zinc chloride and hydrogen gas is released. Let us balance it. Yes. So this is the reaction. So answer is your option B. Now, which gas is evolved when metal reacts with acids? There is only one gas evolved, as we have seen in the table, that is your hydrogen gas. Whenever carbonates or bicarbonates comes, there comes the evolution of carbon dioxide. As always, hydrogen gas is evolved whenever it reacts with water or acids. Which of the metals does not react with dilute acids? So which will not react? Now we have seen 4 elements, out of which one is copper. So copper is least reactive, so it do not react that well with dilute acids. Now the reaction of metal with acid is an example of which type of reaction? We have just seen it. It is a displacement reaction. Either it reacts with acid or salt solution. Now which metal reacts vigorously with dilute acids, producing hydrogen gas? So now when I use this word vigorously, it should just be clicked in your mind that I am asking about most reactive element. Now which one of these is the most reactive? That is sodium. So it will form sodium salt. Now when an iron nail is dipped in copper sulfate, so you just have to write these two. Then just observe, is iron is more reactive than copper? Yes. Then displacement reaction will occur. So what will be formed? Iron sulfate and copper will be released. It will be deposited on the iron. Okay, so this copper will be deposited as the reddish brown layer in the iron itself. Okay, so here iron displaces copper from copper sulfate. Okay, now next question. Which of the following metals can displace zinc from zinc sulfate? So now if you have to displace any metal, then that metal should be more reactive. So if you have to displace zinc, then you have to choose that metal which is more reactive than zinc. Then again it comes to your reactivity series. So which is more reactive than zinc? Okay, so magnesium is there. Okay, so the answer will be magnesium. Now a blue deposit forms when zinc is added to copper sulfate solution. Why? Because if any deposit is forming, that means the reaction is happening. And which reaction is happening here? Displacement reaction. So single displacement reaction occurs here. We get zinc sulfate and copper is released. Copper forms a layer, reddish brown layer on zinc, and we get a blue solution that is nothing but your zinc sulfate. So zinc is more reactive than copper. Now no reaction occurs when silver. Now mostly silver and gold shows no reaction. Okay, whenever added to anything. Why? Because they are the least reactive metal. Okay, so this was all about your physical and chemical properties. Okay, now we are left with two topics. One is your formation of ionic compounds, how sodium chloride, magnesium chloride, all of these are formed. Okay, and then your metallurgy part. Okay, so let us start your formation of ionic compounds. Just give me a minute. Let me drink some water. Then we'll move further with formation of ionic compounds. I hope it is clear till now. Now if you are having any doubts till now, you can ask me. Okay, so now let's move on quickly to formation of ionic compounds. Now this you have been learning since your 9th grade. In 9th grade you have learned in detail that how ionic compounds are formed. Okay, I'll just give you a brief knowledge about formation of ionic compounds with some examples. So what are basically ionic compounds? So the word itself says beta ionic means ions, and as you all know there are two ions, cations and anions. So if you have to form ionic compounds, then one should lose electron and other should gain it. So these are those compounds which occur by complete transfer of electrons. As I have told you, one will lose electron, other will gain. From metal to non-metal. As metal loses electrons to form cations, non-metals gains electrons to form anions. So metal will lose electron, it will form positive ion, that is your cation. Non-metals will gain that electron, it will form negative ion, that is your anion. Now what is that force due to which this reaction occurs? So the force that is forming this ionic compound, or that is holding these two opposite ions together, that is nothing but your strongest force, that is your electrostatic force of attraction, and this is your strongest force. Okay, now ionic bond. Now this is the bond that is formed because of this electrostatic force of attraction between opposite charged ions. So because of this electrostatic force of attraction between opposite charged ions, between cations and anions, ionic bonds are formed and they are very strong. So it is formed between metal and non-metal, it involves transfer, no sharing, and it results in formation of ionic compounds. So this was about ionic bond or electrovalent bond. It is also called electrovalent bond because it is related to the valency of electrons. Now let us see the two examples, that is of sodium chloride and magnesium chloride. Now if someone of you not be knowing this topic that clearly, then it will be clear to you. So as you know that sodium has a atomic number of 11, so configuration is 281. Now in order to gain stability, it will lose one outermost electron, it will form sodium ion. Now in the second step, this chlorine gains this one electron and forms chlorine ion in order to become stable. Okay, so sodium here loses electrons, form cations. Now chlorine here gains electrons, form anions, and in the third step, these both unstable ions will combine together to form a stable compound that is nothing but your sodium chloride. Okay, so this is how an ionic compound forms. Okay, now this is very important for exam. I have mentioned here also electronic structure, electronic dot structure can be asked for any of the ionic compounds. Mostly sodium chloride, magnesium chloride, aluminum chloride, these are some common compounds. So we'll see the how to form this electron dot structure of two compounds, that is sodium chloride and magnesium chloride. So let's start with sodium chloride. So now sodium has 1 valence electron, chlorine has 7. So 1 electron will transfer from sodium to chlorine and both will attain stable octet configuration. And now this is a diagram based question that is asked in your exams. So you have to draw the diagram. Now how to draw the electron dot structure? That is very important. So as you can see here, these are two structures that I have made for you. One is your sodium chloride structure and one is your magnesium chloride. Now you have to draw this structure in the exams. Okay, if questions comes from these topics. So as you can see how I have drawn NaCl. So now I just have drawn the outermost shell. You can also draw it like this, the outermost shell, that it has 1 electron, chlorine has 7. So this 1 electron will be transferred. Now it is left with Na plus, it is left with Cl minus, and that is how NaCl forms. Or you can draw it like this also. This is a detailed one. So now for MgCl2, magnesium chloride, now if you will draw the structure of magnesium, you will find that there are 2 electrons in the outermost shell. Okay, now to form magnesium chloride, now chlorine only needs 1 electron. So what will happen? Now 1 electron goes to 1 chlorine atom, another electron goes to another chlorine atom, and likewise as you can see here, Mg loses these 2 electrons, forms Mg2 plus. Each chlorine will gain that 1 electron, it will form Cl minus, and likewise MgCl2 is formed. Okay, so you must know how to draw the electronic dot structure of any ionic compound if asked in the exam. Okay, then now let's move on. So now little bit theory what you have to write. So why these ions form? So atom forms ions, 2 reasons. First, stable electronic configuration, they want to gain electrons or lose electrons to form stable electronic configuration. Now what is stable electronic configuration? Now that is nothing but your octet rule. So they want to get inert like their noble gases. They want to have 8 electrons in their outermost shell so that they can achieve stable electronic configuration. And why they want to achieve? Because they want to complete their octet and they want to follow this octet rule, they want to get stable. Now hydrogen and helium, as they are only having 1 or 2 electrons, that's why they follow duplet rule instead of octet. Rest all the elements will always fall under octet rule. Okay, next, properties. What are the properties of this? Now since ionic bond is the strongest one, okay, that's why it will be hard and present in the form of solids, and it will be brittle also. Now talking about melting and boiling points, so if the electrostatic force of attraction is so strong, then it will be difficult to break this bond. That's why it has high melting and boiling point, because of these strong electrostatic forces. Okay, now these questions are mostly asked under give reason. Okay, now why ionic compounds are hard or crystalline or brittle, or why they have high melting and boiling points. Now I am also telling you along with the topic that how and what questions can be asked from this particular topic. Now let's move on. Solubility. Now they are generally soluble in water because ionic compounds, as they are formed of ions, so they will be easily soluble in water. Now those compounds that are soluble in water, they are insoluble in some other solvents like petrol, kerosene, oil, benzene. Okay, and since water is a polar solvent, so it is also made up of ions. Okay, hydronium ions and hydroxide ions. That's why they are generally soluble in ionic compounds. Okay, they also conduct electricity. Now since they are easily soluble, then they will conduct electricity. Okay, as you know that if you have to conduct electricity, then the solution must be present in molten state or in liquid state. So it will only conduct electricity when it is present in molten or aqueous state. In dry state, like dry salt, it will not conduct electricity. But if you put it into water or in some aqueous solution or it in molten state, then it will start conducting electricity. Okay, so in solid state, it will not conduct electricity. Now these questions have asked once in the exams that why it doesn't conduct electricity in solid state. Because in solid state, ions are compactly packed, so they are not ready to move in solid state. Okay, and they are free to move only in either molten or aqueous state. Okay, yes. Now some key points. So what was the summary of this topic? That it is formed by transfer of electrons, strong electrostatic force of attraction, then high melting point and boiling point, then it can conduct electricity in molten or aqueous state, and it is soluble in water. Now a give reason can be asked from any of these points, or you can be asked to write or draw the electron dot structure of any ionic compound. Okay, so this was all about ionic compounds. Now the last topic of this chapter, then we'll be solving PYQs. Okay, so extraction of metals. Now one question definitely comes from this topic. Mostly they are either case based, source based questions, okay, some assertion reason, okay, or some MCQs. So what is extraction of metals? So you know that beta, I've already told you in the start of this chapter that there are some metals that are found inside earth crust. They are very reactive, but they are found in the form of minerals and ores, and we have to extract pure metal out of them. They are not present in free state or in pure form. Okay, so some of the most reactive metals. Okay, so to obtain pure metal from its ore that means useful mineral, then that is called your extraction of metals. Okay, and that part of your chemistry is called metallurgy. Okay, so let's learn something about metallurgy now. Okay, now what are the steps that is followed in this extraction of metals? So now this is very important. So remember these 3 steps, because I will be asking questions related to this. This has been asked in every year's question paper. Okay, so now there are 3 steps. Now the first step is, when you bring that ore out from the earth's crust, first you will concentrate that ore. Now what do you mean by concentrate? Now by concentration of ore, we mean that to remove those impurities which are not soluble. So those insoluble impurities like sand, soil, etc., which we call it slag. Now we have to remove these impurities first. Now that is called concentration of ore. Okay. Now remember that ore that we are getting from the earth crust, that will either be obtained in 2 forms. Okay. Now either that will be a sulfide ore or that will be a carbonate ore. Okay, now this topic is very important. Now if that ore is your sulfide ore, then you will do the process of roasting. Now what is roasting? You will heat that sulfide ore in the presence of oxygen or air. Now why will you heat that ore? To form oxide. Now here you will be getting metal oxide. You will not get the metal directly. So it is in steps. So you will get the metal oxide here. Okay, now if you'll get the carbonate ore, if it's carbonate ore, you'll follow the process of calcination. Now here what we'll be doing, you'll be heating that carbonate ore in the absence of air. So remember, roasting, sulfide ore, presence of air, calcination, carbonate ore, absence of air. Okay, in both the cases you will be getting metal oxides here. Okay, so this is the second step. Now you have to reduce this oxygen, then only you will be getting metal. So now reduction should be conducted here. Now what is reduction? So reduction is loss of oxygen. So for reduction you need a good oxidizing agent. Okay, so you will convert this metal oxide into metal. Now let's see some examples that are mostly asked in exams related to this topic. Now first let's see that which metals are found in which state. Okay, and that depends upon your chemical reactivity series. So now, based upon this reactivity series, some are that you already know that low reactive metals like gold, silver, platinum, they are already found in free state. Okay, so you don't have to do anything to them. Okay, now if there are some medium reactive metals like iron, zinc or lead, now for them you use carbon to reduce. Okay, so we reduce these elements using carbon to get them into their free state form. Okay, as you know that carbon readily forms carbon dioxide. So you can use carbon for reduction. It is, yeah. Now highly reactive metals. Now these highly reactive metals like sodium, potassium and aluminium, now you will not reduce it with carbon or anything else. So for now here we will be using electrolytic method. So you will be using electric current to extract pure metal from its ores. Okay, so this is very important, that for which kind of metals you will follow which extraction method. Now this is a summary of this topic, beta. So as you can see, I have divided into 3 different topics, that if the concentrated ore is present of highly reactive metal, if it is presented of medium reactive metal, and if it is less reactive metal. Now if it is highly reactive metal, we will directly do the electrolysis in molten form. Okay, because in dry form it will not conduct electricity. So in molten form you can do the electrolysis, you will directly get the pure metal for sodium, potassium, aluminium, these kind of metals. Now for medium reactive metals like zinc, copper, iron, you will find that either it will be extracted in carbonate ore form or sulfide ore form. If it's carbonate, then calcination in the absence of air. If it's sulfide, then roasting in the presence of air. And in both the cases you will be getting metal oxides. Then you will be reducing that metal oxide either with carbon or aluminium, common oxidizing agents. Then you will be getting, again you will be getting the impure metal. Now this is also not 100% pure. So for 100% pure metal you will be refining this metal. Then only you will be getting a pure metal form. Okay, now if it is less reactive metal, then mostly less reactive metals are present as sulfide ores. So you will be doing roasting here in the presence of air, then you will be directly getting impure metal. Okay, you will not be getting metal oxide since they are less reactive. Okay, and then you will be refining, and then you will be getting a pure metal. So this is all about how will you extract these metals from their ores. Okay, now 2 important examples which have mostly been asked in exams. Okay, about iron. Now iron is the most common metal that is being used. Okay, and aluminium. So let's discuss it one by one. So if I will talk about iron, now the most common ore of iron is your hematite. It is Fe2O3 iron oxide. Okay, now it is reduced using carbon. Okay, carbon is the common oxidizing agent that is used here. Okay, and you can see the reaction as well. Now this is iron oxide 2. Then it is reduced with carbon monoxide, and you will be getting the impure iron metal along with carbon dioxide. This is impure, then you have to refine it, then you will be getting a pure iron. Okay, so this was about hematite. Okay, now aluminium, if I'll talk about aluminium, aluminium comes under the category of highly reactive elements. Then we'll do electrolytic refining method. Okay, now the most common ore of aluminium is bauxite, that is aluminium oxide. So mostly ores of highly reactive metals are already present in the form of oxides. So you only just have to, using electrolysis, you just have to refine it. Okay, so now it cannot be reduced by carbon or some other oxidizing agent because they are highly reactive. Okay, so that's why you will use electrolysis in molten form, then you will be getting the pure aluminium metal. Okay, so this was about extraction of metals, highly reactive metals, electrolysis, medium reactive metals, reduction with the help of carbon, because carbon is the most common oxidizing agent here. Now for low reactive metals, it is already found in free state. Yeah. And the last subtopic in this topic only is your corrosion. Okay, so what is corrosion? Now corrosion we already have studied in each of the previous chapters. Okay, so we'll just go on through it quickly. So it is nothing but the destruction of metal. It occurs, the most common example is your iron rusting, and it forms iron oxide, hydrated iron oxide, Fe2O3.XH2, as you can see here. So the most common example, it occurs in the presence of air and moisture, that is oxygen and moisture. Okay, and this is an example rusting of iron. It is nothing but hydrated iron oxide, which is formed like this, and this is the formula of hydrated iron oxide that you call rust. Okay, now what are the conditions of this rusting? So these are some common conditions: oxygen and moisture. Now any one of these is absent, then there will be no rust formed. Okay, make it clear. Now what are its effects? It will weaken the metal structure and it will cause heavy economic loss. What are the methods to prevent it? You already know it all. So the common methods are painting. You can prevent the direct contact with air or moisture. You can oil or grease it, especially for machineries. You can galvanize it. Now this is important. I will put a coat of zinc over it, so it will protect the iron that is inside it. Now alloying is also important. Now we'll see the alloys after this slide. What is alloying basically in detail? So it also provides a resistance to corrosion. Okay, it doesn't get easily corroded. For example, stainless steel. Okay, now stainless steel is not pure iron, so it doesn't get rust easily because of alloying. Okay, now alloys. Okay, let's learn about alloys little bit. So we have learned about metalloids. Metalloids is nothing but a combination of properties of metals and non-metals. It is basically used in the semiconductor region. Now what are alloys? Now alloys, there is a difference between metalloids and alloys. For metalloids, they are commonly the mixture of properties of metals and non-metals. For alloys, it can be a mixture of two or more metal itself, or it can be a metal and non-metal. Okay, it can be any one of these. Okay, now why we use alloys? What are its uses? If we have metals and non-metals, then why do we mix it and why to use the mixture of them? Okay, so there must be some reason, some important reason. Because of that we use alloys most often. Why do we use it? So this is important because they're stronger than pure metals. Because if you are mixing two metals, okay, then you are making it even more stronger. You are mixing the properties also. And it is more resistant to corrosion. Now it will not get corroded easily and it looks better in appearance also. Now some important alloys. Now this is very important for board. Focus on these. Okay, so these are some important alloys that is asked in previous year question papers. Okay, now they do not have fixed melting points beta. Why? Because they are the mixture of two different elements. That's why their melting points and boiling points are flexible. It varies depending upon it is made up of which kind of metals or non-metals. Now these some common important alloys. So brass, copper and zinc. Utensils, you have seen the brown colored brass, copper and zinc, the mixture of copper and zinc in utensils. Okay, in Asia times it is used most probably. Bronze, you have seen the bronze medal, it is made up of copper and tin and it is used in making statues and some medals also. And you have seen steel. So just now I have given the example of stainless steel. It is the purest form of carbon. Okay, that's why it shines so bright. So it is nothing but the mixture of iron and carbon. So if the carbon is very less than 4%, then that is called as stainless steel, purest form of steel. Okay, and it is used in construction. Now in construction, the steel that we use mostly contains more carbon than those steel that we use in our daily life in utensils. Okay, now some questions, then we will be solving PYQs. Okay, some questions related to these ionic compounds and your metallurgy, corrosion and alloys. So ionic bond, when ionic bond forms, so whenever ionic comes to your mind, different ions, so they will transfer electrons. So your answer is B. Next, which pair will form an ionic compound? Okay, so the ionic compound, so sodium and chlorine, as they form cations and anions. Now which compound has ionic bonding? So ionic bonding, just your mind should strike into opposite ions. So here again sodium chloride, rest all have covalent bonds. Now why do ionic compounds have high melting points? So I have already told you the reason. Since ionic bonds have strong electrostatic forces, because of that it has high melting and boiling point. So your answer will be strong electrostatic forces. Next, ionic compounds conduct electricity in. Now I have already told you nothing can conduct electricity if it is present in solid state. So it has to be in molten state in order to conduct electricity. Now the concentrated ore obtained after removing impurities is called concentrate. Which process is used for sulfide ores? Now we have already studied that it is roasting in the presence of air. Metal extracted by electrolysis is, so by electrolytic refining, most reactive metals, highly reactive metals, out of them is aluminium. Bauxite ore, I have already told you, we have seen that. Which metal is found in free state in nature? So if I will talk about free state in nature, then it will be the least reactive metal, and that is gold. Now which metal cannot be extracted using iron? So if I am saying cannot be extracted using iron, then that should be those metals which are extracted using electrolytic refining method. That is again aluminium, highly reactive metal. What is rust? Now I've already shown you the formula. It is nothing but hydrated form of iron oxide, Fe2O3.XH2. Which method is used to prevent rusting of iron? So out of them it is galvanization, putting a layer of zinc in iron in order to protect iron from rusting. Okay, so now this was all about the whole chapter of metals and non-metals. I have tried to keep focus on each and every topic from basic, from scratch up to the highest level from where questions can be asked, and we have solved so many MCQs also to make the topic more clear, okay, and more specific to you all. Now we will be solving some PYQs, especially those questions that has been asked in last 4 to 5 years, to make you clear that which kind of MCQs, 2 marks, 3 marks, 4 marks, case-based study questions and assertion reason questions have been asked in previous exams from this chapter. Okay, so let's start the PYQs. So now, which the metals obtained from there, and I need answers from all of you. Okay, so try to answer it. Okay. Now the metals obtained from their molten chlorides by the process of electrolytic reduction. So as soon as the electrolytic reduction comes to your mind, you must be focused that in electrolytic reductions, it should be highly reactive metal. And which of them is highly reactive? Aluminium. So your answer will be aluminium and silver. Just look into the keywords. Here the keyword is your electrolytic reduction. Next. The most common method of extraction of metals from their oxide ores. Okay, now I have told you the most common oxidizing agent we use in extraction of ores is reduction with carbon. Okay, so in order to reduce the oxide ore, we use reduction with carbon. Now relation between two elements A and B forms a compound C. Now A loses electrons and B gains electrons. So it is clear that it is ionic compound. Okay, if one is losing and one is gaining, it is ionic compound. Now, which one of the following properties will not shown by compound C? Now, A and B is forming an ionic compound. Then, which is not shown by compound C? So, it has weak electrostatic force of attraction between its oppositely charged ions. Okay. Next. Aluminium powder is used in thermite welding because. Now this is also a very important question and very important topic. Okay, so in thermite welding, to join those tracks in railway tracks, aluminium powder is used, and that is called thermite welding. Okay, now why it is used? It is used because when it is heated with iron 3 oxide, molten iron is obtained. Okay, and that molten iron is used to fix that welding process. Okay, that's why this is very important. Okay, so you can see the reaction also, aluminium with Fe2O3. Then since aluminium is more reactive than iron, it will form Al2O3 and you will get this iron which is in molten form. Okay, and you can use this iron to join this railway tracks. Okay. Now the products formed when aluminium and magnesium are burned in the presence of air. So aluminium forms aluminium oxide beta and magnesium forms magnesium oxide. You all remember the formula? So your answer will be option B. Now a metal M, next question. A metal M displaces iron from, it is displacing iron from iron sulfate. Okay, so there is iron sulfate and there is one metal that is displacing iron and forming this metal sulfate, and iron is displaced. So this should be reactive than iron. Okay, now which of them is reactive than iron? Obviously magnesium. So it will be your magnesium. It forms magnesium sulfate. Now the color of the solution observed after 1 hour of placing nails. Now nails are mostly made up of iron. Now if you put iron in copper sulfate, you all know that iron is more reactive than copper, so it will form copper sulfate solution, iron sulfate solution, and copper is deposited on iron. Okay, then the solution will turn from blue to pale green. Now these we have seen in first chapter also. So this is very important question regarding your board exams. Next, some assertion reasons, then some question answers. So hydrogen gas is not evolved when metal reacts with nitric acid. Now nitric acid is a strong reducing agent and it reduces the oxygen, it reduces the hydrogen produced in the reaction to water. Now since nitric acid is very reactive, so it will not break down and hydrogen gas is not evolved, okay. But it is saying nitric is strong reducing agent, and yeah, so both assertion reason are true and it is the correct explanation too. It reduces and strong reducing agent, it reduces the hydrogen produced in the reaction to water. So what is the reason saying that nitric acid is a strong reducing agent and reduces the hydrogen produced in the reaction to water? Yes. Now the metals high up in the reactivity series cannot be obtained from their compounds by heating with carbon. Yes, because they use electrostatic, electrolytic your refining method. Yes, so that's true. Now displacement reactions can also be used to obtain metal. Okay, now second one is false. So assertion is true but reason is false. Now here displacement reactions can be used to obtain metal but it is not related to this. So instead of this option you can also mark both are true but reason is not the correct explanation for assertion A. Why? Because we have seen that in displacement reactions highly reactive metal displaces it from less reactive solution. Now in common practice silver is recovered from silver nitrate solution by using copper metal. So what does it forms? It forms copper nitrate. Now name the type of reaction. So let's see the reaction. So copper plus silver nitrate will form, since copper is more reactive, copper nitrate, and we'll get the silver metal. So this is the reaction, first part. Second part, name the method used for refining silver. So now to refine silver, okay, now silver is already present in free state. Okay, it is already present in free state, as we have already seen that most reactive elements like silver, gold, platinum, they're already present in free state. Okay, and still if you want it, you can use electrolytic refining method. Okay. Cinnabar, what is cinnabar? This is an important question. So cinnabar is nothing but your HGS, mercuric sulfide. Okay, so it is an ore of metal X. So now here you directly got X. X is nothing but your mercury. Now when this ore is heated in air, so when you will heat it in air, what you will get? You will get mercuric oxide and mercuric oxide, okay, and that is your XO, and then reduce to metal X on further heating. Okay, so you will also get this. Yeah. Now on further heating, what happens? On further heating, it is reduced to metal X, so you will get pure mercury. Okay. Now state the formation of, show the formation of magnesium chloride. Yeah. Show the formation of magnesium chloride. We already have seen the formation of magnesium chloride beta. I have already shown you the electronic configuration and that electron dot structure. Okay, cation and anion. So your cation will be Mg2 plus, your anion will be Cl minus. Okay, now how is zinc extracted from its ore? Name the process involved in the extraction, write chemical process for the reaction that occur during its process. Okay, so now zinc is present in the form of zinc blend, that is zinc sulfide, so sulfide ore. Okay, now if you react it with carbon monoxide, it will convert into oxide. Okay, it will get converted into zinc oxide. Okay, now you can get zinc, no, first let's do one thing, just a second. Yeah, let's do one thing, that instead of doing directly reduction, first convert it into oxide. So let's first convert it into oxide. Okay, so on heating in the presence of air, it will form zinc oxide. okay, and sulfur dioxide. Then again, if you reduced this zinc oxide with carbon, then you will be getting zinc plus carbon monoxide. So likewise, you can obtain this zinc from zinc blende, that is its ore. Okay, and which process is used here? Roasting is used here. As this reaction is present in sulfide form, so in the presence of oxygen only this reaction will occur. Now name two metals which reacts violently with cold water. Now we have already seen those two elements, the most reactive elements, potassium, sodium, that react with cold water. Okay, now any three observations which a student notes when these metals are dropped in a beaker containing water. Whenever you drop these metals in a beaker containing water, potassium will form potassium hydroxide, sodium will form sodium hydroxide instantly. Okay, and whenever you put it into water, then hydrogen gas is released. You can observe it with a popping sound and with bubbles also, and this is a violent reaction. Now test to identify the gas evolved, so that is a popping test. You can put a matchstick in front of that solution that is formed, then you will observe that it forms a popping sound and bubbles are also obtained for highly reactive elements. Now displacement reactions play a key role in extracting metal in the middle of the reactivity series. Justify the statement with two examples. Now we have seen just two examples, okay, of your reactive elements, okay, like aluminium and iron. We have seen those two examples. Okay, so as we have seen it, okay, that displays. Now I have just shown you here also. Okay, now since zinc is more reactive than carbon, it will be reduced to zinc and carbon forms carbon monoxide. Okay, so now why does metals high up in the reactivity series? Okay, now this, as I have already told you, I hope it's clear to you all that displacement reactions is very important, because a highly reactive element can displace a less reactive elements, especially those middle reactive elements, from its salt solution. Now I have already explained you the examples also better. Okay, now why can metals high up in the reactivity series not be obtained by reduction of their oxides by carbon? Because metals like your highly reactive metals, okay, like your aluminium, okay, potassium, sodium. Now potassium, sodium is not present in the form of its ores, but like aluminium, okay, highly reactive metals, they cannot be obtained by reduction of its oxides by carbon, okay, because they cannot be easily broken down from its ore, because they are highly reactive. Okay, they'll again form the compound. So that's why we have to use electrolytic refining. We have to use electrolytic refining for its extraction. Okay, because without passing electricity, you can't form this pure form of aluminium or any highly reactive metal. Now name and describe the most widely. These are very important questions. Go through these questions, okay, in detail. Practice it again and again, and practice it by writing. Don't practice it orally. Okay, I've already discussed everything in the chapter. That's why I'm just giving you the hints in the solutions. But you have to practice it by writing the full answers. Okay, for that just follow this video and just make the notes out of it. Okay, or save it. Now name and describe the most widely used method for refining impure metals. Okay, so the most common method that we have seen is first concentration of ore. Then in the second form, if it is present in sulfide form, then roasting. Okay, in the presence of air, then we'll get metal oxide. If it is present in carbonate form, then it is calcination. In the absence of oxygen, here also you will be getting oxide. Okay, then in the third process, the oxide, you will reduce it using oxidizing agent. Then you will be getting a impure metal. Then you will be refining that metal. Then you will be getting the pure metal. So this is the most widely used method for refining impure metals. So you have to write the process along with any one example. You can give the example of zinc, iron, aluminium. Remember the examples of, learn the examples of iron and aluminium. That is very important. And you can put that examples in any question that is asked from this topic. Yeah. Now, Consider the following metals. Now here some metals are given, as you can see here. Now what is asked? So now it is asked that this is kind of a name one word answer. So which metal do not react with oxygen even at high temperature? So which metal do not react with oxygen even at high temperature? So that is silver, because it is the least reactive. Which reacts the oxygen at ordinary temperature and form the protective oxide layer? Now this is the hint. Protective oxide layer, it is nothing but aluminium. Now catches fire when put in open, so violently reacts. So the violent of all of them is potassium. Now does not burn in oxygen, but the hot metal is coated with black colored oxide layer. Now as soon as black colored layer comes, I have already told you, your answer is copper. Now amphoteric oxides, now those oxides which react with acid and base both to form acetic and basic salt, and the examples I have told you is aluminium and zinc. Okay, so now you can take the example of aluminium Al2O3. It also reacts with HCl and it forms aluminium chloride. You can write the balanced form of reaction, and it also reacts with NaOH, a base, and it forms sodium aluminate. Okay, so both reaction is possible. Now what are alkalis? So alkalis are those solution of metals or bases in water. Okay, so those highly reactive metals that are present in aqueous solution in water, these are called alkalis. Now like sodium hydroxide, potassium hydroxide, all of them are alkalis. Now questions will be asked in this form only, beta. Okay, even if a 4 mark or 5 mark question comes from these chapters or from chemistry section, it will be divided into 3 or 4 subparts. So you have to write less, you have to write pinpoint. That is more important. Writing more is not a solution. Now if you doesn't know the exact solution of some question, then you can take it like that, you can write something related to it. But else just try to write pinpoint answers. Even if you write limited but write pinpoint, you will be getting full marks. Okay, so now last few questions. Many pure metals like copper, iron and gold are very soft and are considered unsuitable for certain uses. Metallic objects around such as utensils, statues, ornaments, guns, etc. are actually not made up of pure metals. Instead of pure metals, alloys are used. Okay, what is the primary constituent metal of an alloy? Okay, so now this is a question related to alloys. So how does electrical conductivity and melting points of a metal change when it is converted to alloy by mixing small amount of element in it? So now electrical conductivity will increase. Okay, and what will be the change in its melting point? We have just seen it in alloy section, that its melting point, we have just seen it. I'll just revise you all. Okay, so we have just seen it in alloys, as you can see here. Yes, so as you can see here, it does not have fixed melting point, so it will vary. That we have seen it in alloys. Okay, so as we have already seen it here, pure metals, you know that your conductivity and melting point is maximum. Now when you convert into alloy by mixing a small amount of element, it will somehow vary both this electrical conductivity and your melting point will vary, beta. Okay, melting point will vary, it's flexible. Okay, now if you are mixing a small amount of element, now if you are mixing a metal, then it will increase, and if you are mixing a non-metal, then it will decrease. Now name an alloy used for welding. Now that is solder. Now you all have heard about soldering, you must have seen also, that is used to join two electric wires, okay, in an electric circuit. Okay, these are it is made up of tin and lead. Okay, now what are alloys? Alloys is nothing but a homogeneous mixture of two or more metals or a metal and a non-metal. How is brass prepared? Now I have already told you brass is a combination of copper plus zinc. Okay, so it will combine to form brass. Next, some more questions. Oxides of aluminium and zinc are amphoteric. The metals which are found in both in free state and combined state are copper and silver, because they are least reactive elements. Okay, but even least than them is gold and silver. So let's write gold and silver. Now sometimes two options might be given, so then you have to choose one out of them, then you have to choose the most safest option. So here it's gold and silver. Okay, but now there is a trick. Now you can write gold and silver also, you can write copper and silver also. Okay, now in gold and silver, both of them are present in free state. Now if I write copper and silver, then copper is present in, now here copper is present in combined state also. So now I have to write which are found in both free and combined state, then I'll write copper and silver. Because gold and silver are already found in only free state. Yes, beta, you can ask your doubt if you have any. Then a metal is used in thermite process. I already have told you that which is that metal that is used in thermite process. Iron with aluminium oxide. Now when X is heated with oxygen, it gives an oxide Y. Okay, so this is aluminium, nothing but aluminium that is used in thermite process. Okay, and when it reacts with oxygen, it forms aluminium oxide. It is amphoteric. So the answer is option B. Next, last few questions for this chapter. So one source based questions divided into 3 parts. Okay, so now the metals produced by various reduction processes are not pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Okay, now these we have seen. What is the cathode and anode? So always remember, anode is impure metal, always, and cathode is your pure metal. Cathode is your pure metal always. Now what happens? The metal from the anode gets dissolved into the salt solution. From the salt solution, it gets deposited into cathode. Now in the last, the anode is left nothing with impurities beyond it, that is called anode mud in the bottom, and cathode is your pure metal. After this, electrolytic refining. Okay, in the solution used in the above process, it is the salt solution of the metal salt solution which you have to refine. And like if you are taking zinc, then you can use zinc sulfate. Okay, iron, then iron sulfate, copper, then copper sulfate. How does copper get refined when electric current pass it in the electrolytic cell? Okay, so now if I have to refine copper, then what I have to do? I have to take an impure copper as copper anode, I have to take pure copper strip as cathode, and I have to use copper sulfate solution as electrolyte. So in electrolyte, I'll use copper sulfate solution. Okay, then what you will see? You will see that you will be getting a pure copper at the cathode, and you will be getting the mud and the anode. You have 2 beakers A and B containing copper sulfate solution. What you will observe, after about 2 hours, if you dip a strip of zinc in beaker A and strip of silver. So if I put a strip of zinc in copper sulfate, then as you know that zinc is more reactive, it will form zinc sulfate and copper will be deposited on the zinc. Okay, and in the second part, if you dip a strip of silver in copper sulfate, now silver is less reactive than copper, then no reaction is possible. Next, assertion reason based questions. So now different metals have different reactivities with water and dilute acids. That's correct. Okay. Now extraction of a metal from its ore depends upon its position in the reactivity series. That's also correct. But both of them have no relations. That's why both are true, but it is not the correct explanation for State reasons. Zinc oxide is amphoteric oxide. I have already told you about zinc oxide beta ZnO. It can also react with base. It can also react with acid. Okay, here it will form zinc chloride, water. You can balance it. Okay, now if I balance it 2, 2, 2 and 4. Now this is balanced. Okay, now if I see the base reaction, then NaOH, it will be NaOH, yes, NaOH, and it will be formed Na2ZnO2. Okay, sodium zincate along with hydrogen. Okay, so now along with water, yeah, so it will be, now you can balance it. Okay, so now this is the reaction. Now why sodium metal is stored in bottle filled with kerosene oil? We already have discussed the sodium, potassium, lithium. These are highly reactive elements and they vigorously react with water and air. Okay, that's why if I will not store that in kerosene oil, it will vigorously react with air. So to prevent that reaction, it is stored in kerosene oil. Now in the reactions of nitric acid with metals, generally hydrogen gas is not evolved, because if I react any metal with nitric acid, okay, let's take a metal. So basically what happens when you react any metal with nitric acid, now hydrogen gas is not evolved, because in order to evolution of hydrogen gas, now nitric acid should be able to reduce this hydrogen gas. Okay, but this hydrogen gas is not evolved because hydrogen gas cannot be reduced with the help of nitric acid, as nitric acid itself is a very highly oxidizing agent. Okay, so it cannot reduce this hydrogen gas. That's why hydrogen gas is not evolved. Okay, now state giving reasons the reduction process to obtain the following metals from their compounds. Now mercury, you know that it is present as cinnabar HGS, so we'll use reduction with the help of carbon. Okay, reduction with carbon. Copper cannot be reduced with carbon beta. Okay, why? Because copper is less reactive than carbon. Okay, now if I have to reduce copper, okay, now you can this copper is present in the form of carbonate. Okay, it is present, so calcination happens here. Now in the first one, mercury roasting happens here. Okay, now you will be getting copper oxide. Okay, and then you can reduce, you can reduce it with the help of oxygen, and then you will get you can reduce it with the help of copper, then you will be getting, so you can use here carbon and you will be getting copper metal. Now sodium, now we have to use electrolytic refining. Okay, now state giving the reason change in appearance. Now if I'll talk about change in appearance, then silver, it becomes black on reaction with air, as we have seen with our jewelries, our ornaments. Copper, it will convert from reddish brown to green. Okay, and iron, it will from gray, it is normally gray, it converts it into brown when exposed to air. That is related to rusting. Okay, so this is the color change of all of them. Next question. So these are the variety of questions that can be asked in your final exams. Okay, last few questions. Some metals react with acids to produce salt and hydrogen gas. Illustrate with an example. So let's take any metal, okay, and react it with acid. Now if I take aluminium, react it with hydrochloric acid, it will form aluminium chloride and hydrogen will be released. Now balance it. So now this is the balance reaction. So you can see here salt is formed and along with that hydrogen gas is released. Okay, and how will you test the presence of this gas? It produces popping sound and it gives out bubbles. Yeah, it gives out bubbles and it produces popping sound. So most of the questions comes from these topics only. Okay, it is just twisted and turned, okay, to confuse you. Now there is an assertion reason question. A piece of zinc metal gets reddish brown when kept in copper sulfate because displacement reaction happens here. Zinc is more reactive than copper. Okay, so displacement reaction happens here. So this is correct. Copper is more reactive than zinc. This is wrong. So assertion is true, but reason is false because zinc is more reactive than copper. Next, the following questions are source-based, case-based questions. Read it. Metals are required for a variety of purposes. For this, we need their extraction from their ores. Ores mined from the earth are usually contaminated with many impurities which must be removed before the extraction of metals. The extraction of pure metal involves the following steps: concentration, extraction of metal from concentrated, refining of metals. Okay, these are the steps that we have seen in extraction of metals. Now, what are the questions? Name an ore of mercury. Now, the ore of mercury is cinnabar. We already seen it. It is HGS. Now, state the form in which mercury is present. So, it is present in the form of sulfide ore. So, we use roasting here. What happens to zinc carbonate, ZnCO3? So, it is present in the form of zinc carbonate. So, calcination will happen here. And it will be converted into zinc oxide. Then it will be reduced with the help of carbon to form zinc. Okay. Now the reaction of metal with Fe2O3 is highly exothermic. That means high heat and temperature is released in this reaction and it is used to join railway tracks. So which is this kind of reaction? Beta, this is thermite reaction. So now, what is this metal A? This metal A is nothing but your aluminium. As we have already seen the thermite reaction, which is used to join these railway tracks. Now, chemical reaction, aluminium reacts with Fe2O3 to form Al2O3 and iron, molten iron is released, which is used to, join railway tracks. This is your thermite reaction. Next question. Almost all metals combine vigorously with oxygen to form metal oxides. Metal oxides are generally basic. We have seen it, but some metal oxides show both basic and acidic behavior. They are called amphoteric. We already have seen that also. Different metals show different reactivities towards oxygen. That's correct. Some react vigorously, some do not react at all. So highly reactive elements react vigorously and least reactive elements do not react at all. What happens when copper is heated in air? So now what happens when copper is heated in air? So now when copper is heated in air, it will form copper oxide. And this is nothing, we have seen the reaction. This is nothing a black colored compound. You already have seen it in previous chapter also. Okay, now why are some metal oxides categorized with amphoteric? Because zinc and aluminium, like these oxides, like Al2O3 or ZNO, they can react both with acids and bases to form acidic and basic salts. We have already seen the reaction in previous questions. Okay, so now last few questions. Now complete the following reaction. So Na2O plus H2O, simple reaction, oxide with water, what it will form? Hydroxide, sodium hydroxide, and along with that, which gas will be released? Hydrogen gas. Now you can balance it. Now will be 2 here, then we already have 2, then we have 4. So it will be, so it will be forming NaOH only. Now it is balanced, I think. 2 oxygen, 2, it is balanced. Now aluminium oxide plus NaOH, so now this is oxide and this is base, so it will be forming Na2Al O2. Okay, and this is nothing but your sodium aluminate. This is a salt, sodium aluminate, that is formed along with the release of hydrogen gas. Okay, no, water. You can write water 3 plus 2 5, so you can write 2 here. NaAlO2. Yeah, now that's correct. Now NaAlO2, is it balanced? Let's see. NaAlO2, now if I'll write 2 here, Al is 2, now O is 5, so O becomes 4. Yeah, now it's balanced. So 2 Na2 AlO2, and that is sodium aluminate. Now on burning sulfur in oxygen, a colorless gas is produced. Okay, so name the gas formed. Now if I burn sulfur in oxygen beta, I'll be getting the SO2, that is sulfur dioxide, and it is a poisonous gas that is present in air and that forms sulfurous acid, okay, and sulfuric acid, and that mixes with the rainwater and forms acid rain, okay, and it is acidic in nature. Now what will be the action of these gases on a dry litmus paper? Now we already have learned it in previous chapter that any reaction on dry litmus paper, there occurs no reaction. For any reaction to occur, the reaction will only occur in either in molten state or in aqueous solution. So dry litmus paper, there will be no reaction of that in this gas. Okay, so now this was all about metals and non-metals. Okay, so this was the third chapter of your 10th chemistry for your final exams. Okay, I have tried to give a touch on each and every topic. We have solved MCQs, we have solved so many PYQs, variety of PYQs. Okay, and I have tried to compile the whole chapter in one session. I know it was a tiring one, but it is very important from your board exams. So now even if you are feeling nervous regarding this chapter, now just follow me, go on to this video. Okay, then you will be able to solve this chapter very thoroughly after attending this class. Okay, and for more such interacting and for more such interesting and mind-boggling videos, just download the SISYA Class app, follow our YouTube channel also. Okay, and if you have liked this video, if you have found it useful, if you have found it knowledgeable, okay, useful for your upcoming board exams, then please like, subscribe and share this video to your friends. Okay, it is very useful. Now we'll be meeting soon, very soon, within 2 to 3 days for our next class with very important chapter, carbon and its compounds. Till then, bye bye, take care all of you. Thank you.